as we're working on the logical data model and the physical data model, we might want to come up with something called a schema. And a schema is just an overall description of the database. It usually uses an entity relationship diagram, which we refer to as ERD, and there is a small one that is shown here. So basically, it's just a visual representation of how things are going to be looking. So if I look at this picture, I see that I have an entity called customer. I see that I am storing some columns, the ID, the name, encrypted password, address, and type. These are my columns that I'm storing. And here are the data types. ID has a little key next to it. So this is showing me that this is the primary key. It's an integer. Name, password, address are varchars. Type is a single character. And I see these little arrows which indicate the relationship between the customer entity and the purchase order entity. So this is called a schema. Basically, it's a description of our database. So if you were to draw this out and give it to someone, they will know what entities you are storing information about. They will know what information you're storing. They will know the data types. They will know the relationships between your entities. So this is a schema, and it is just a description of the database. So when I say I want to see the schema, I want to see the description of the database. And usually I want to see it in a visual way, which means I want to see the entity relationship diagram, the ERD. And so if we talk about the different models that we've seen, the external view, and then we've talked about the conceptual view, the logical view, and the physical view, all these data models, we will have different schemas. So an external schema might look like this picture here, where you have different users and you're going to every user and telling them, what do you want to see? And everyone is going to tell you a different thing. Someone's going to say, this is what I want to see. Another person is going to say, this is what I want to see. A third person is going to say, this is what I want to see. So when we talk about external schemas, we are talking about multiple external schemas. Basically, what is everyone's view of how the system is going to work. So we will have different and multiple external schemas to represent the multiple external views that different departments and people that will be dealing with this database have. When we go down and talk about conceptual schema, there's only one. So this is going to include our entities. What entities are we going to be talking about? What relationships we're going to be representing, and sometimes the constraints in these relationships. Those are in the ERD. And here, what this slide did was kind of combine the conceptual and the logical schema, because the logical schema, there's only one schema for that. And again, the physical schema, there's only one. So when we talk about just the word schema, all the word schema means is just a description of what our database is going to be like. And depending on the view, you might have different ones. So conceptual, logical, and physical, you only have one. But when we're talking about the external view, you have several. When we are designing our, when we are coming and doing designs and writing our schemas, we want to make sure that we have some independence. We want logical and physical independence. We want your logical model, the logical model that you come up with should be independent from the database. So we said the database that you're going to be using, the physical model will actually depend on which database you choose and which hardware you're going to be running on. The logical model does not matter which database you're going to be using. So we always want to keep this independence layer there. So when we say data independence, we're just talking about the isolation between the user application and how the data is defined and organized. So when you're talking about how people are envisioning the data and what they want to store about the data, this is different from how you actually store it inside the database. Kind of like the credit card. When you talk to someone, they will say, I want to see the credit card information. When we went down to the physical layer, the physical model, we broke up this credit card into different fields. So at the logical model, you should not be concerned with how things are going to be stored. Okay. The other thing is, when we're talking about data independence, is that we want to make sure that if I ever have to make changes to how my data is going to be stored, I am going to it's not going to affect the user application or the external views that the users told me. We want to hide the complexity of the implementation from the database user. The database user, whoever is running these reports on the database, should not be worried about how complex things are stored. And so when we talk about data abstraction, we only want to expose items that are relevant to the user. For example, I have a user application that stores the customer name. Now, does it matter to me whether the customer name is stored as one field or it's split into first name in one column and last name in another column? It shouldn't matter. So when we are talking about data independence, we want to make sure that the users of this database do not know about how data is going to be stored, and they don't have to worry about how the data is stored. This is a picture of the logical schema. So the logical schema is the conceptual design and the logical design combined together. So here you see that we have our entities, we have our relationships. So the entities and relationships come from the conceptual model, and then our attributes and primary key come from the logical model. So here we are looking at a logical schema, which is both the conceptual and logical design stuck together. What we want to be able to do is be able to change this logical schema and add more columns and change the data types around if we need to, without changing the external schema, what the user's view is. So the user has a view of how things are supposed to be looking. We want to be able to change the logical schema if we need to, without affecting anything really with how the user is going to interact with the system. And so this is called the logical data independence. The data should be independent. How we logically draw it out and organize our data is independent from how the user of this database is going to be interacting with it. And the final thing is physical data independence. We want to be able to make changes to the physical model without affecting the internal logical model. So if anything happens with the file organization or how things are stored, I don't want to be changing the logical schema. So the logical schema that we just drew, we want it to be independent from how we are going to be storing information on the database. And so when we say physical data independence, we want to hide the details of storing information from the actual user. Now, what I'm going to do is I'm going to go through a series of slides that talk about some of the things that happen in the database physical model that we are not going to be really dealing with in this course. So, for example, one of the things in the physical model that you need to think about, beyond this course, is where information is going to be stored. So if you want to store your information right now, the way we're going to do it with Oracle is Oracle creates something called a table space, and we have the default table space and we have one database file. So what we're going to do in this course, we're going to always be using this database file to store information in. Well, you can actually create different table spaces. So it's kind of like a container that different users can view. And so this is the command if you want to play with it to create a table space. But when people are creating table spaces, they need to think of things like the name, where they're going to save the file. So, if you have a computer with several hard drives, do you want to store it on the hard drive that's faster or the hard drive that's slower, for example? What's the initial size of the file that you want to allocate? So how much space are you willing to allocate for this table space in your database? Should it be able to auto extend if it needs more? And if it is, in increments of what? Is there a maximum size that you will allow this database to grow to, so that, you want to limit it so it doesn't take over your whole hard drive? So this is one of the considerations that have to happen in the physical data model. Of course, like I said, this is beyond the scope of this course, but I just have it here for you to see. You can check what existing table spaces are in a system. So if you run this command in our Oracle database, you will find that there are several table spaces that are there, and the files that they usually save them in are DBF. So there's one for like system, there's one for the users, there are different table spaces. You can find information about the existing table spaces, like how big they are, what's the maximum size. And then you can create table spaces, you can delete table spaces. The other thing that I also want to show you, which we're not going to do for in this class, is create user accounts. So right now, when we are using Oracle, we are using the system, which basically is the admin account for the database. Now, when you are creating another user account, you can choose things like authentication method, how the password, table space quota, is the account locked or unlocked, the status of the password, privileges, are you going to give them system privileges? So right now we are logging with system privilege, which means we can do anything. But you can also create users that have object privileges, meaning you tell them that you are only allowed to deal with the students table. And HR, you are only allowed to deal with the faculty table. And maintenance, you're only allowed to deal with the rooms table. So you can assign object privileges to users. So users can only access data that they are allowed to access. And so remember when we talked about security in a database management system makes sure the data is secure. Well, this is how we make sure it's secure. We assign privileges to users based on what they are allowed to see. And then Oracle has like some predefined roles that you can use, but if you want to create users, you can create a user. For example, give them a username, give them a password, and if you want to make them admin, for example, you can say grant DBA to them and grant all privileges to them. So this will make someone kind of have admin privileges like the system account. You can give them specific privileges. So if you grant a username, for example, connect privileges, that means you're allowing them to connect to the database. You can give them specific privileges like selecting on certain tables. So you're allowing them to run reports only on certain tables. Or maybe you want them to be able to select on any table that exists. Maybe you want them to be able to create their own tables. So these are just examples of different privileges that you can assign to different users. Again, we're not going to do this in this course, but I just want to show you that these exist in Oracle, and these are some of the things that have to be dealt with at the physical implementation. This is just a slide that shows you how you can see existing users in there. And in the next video, we're going to start talking about the classifications of database management systems.